Hello guys, I have been getting requests to go over some past paper questions in preparation for the IGCSE and O-level exams. So welcome to my first video for this series. We will start with topic 1, part 1 about experimental design. The exam papers that I am using is from savemyexam.co.uk. If you need a good resource for exam revisions, I recommend this website. Question 1. The fractional distillation apparatus shown is being used to separate a mixture of two liquids. A thermometer is missing from the apparatus. Where should the bulb of the thermometer be placed? The bulb of the thermometer should be placed in this area here, B, so that it can detect the temperature of the vapor condensing to liquid. So when you plot temperature against time, the thermometer reading should increase at first, and then it will stop increasing, and then it will start increasing again. Now, when the temperature doesn't increase, that's when liquid turns to gas. So the boiling point can be identified using this graph. This graph is called the heating curve. Now, the reason why the temperature doesn't rise is because the heat or the energy is being used not to raise the temperature, but to overcome the intermolecular forces of the liquid. Question 2. In the graph, curve 1 was obtained by observing the decomposition of 100 mL of 1 mole per dm cube hydrogen peroxide catalyzed by manganese 4 oxide. Which alteration to the original experimental conditions would produce curve 2? Curve 2 produce more product. That means the number of mole of the reagent must be higher than experiment 1. However, the rate of reaction is slower. So let's start from D delta. Using a different catalyst, a catalyst will not change the final amount of the product produced because catalysts themselves do not react, so they won't give more product. Using less manganese 4 oxide, if there is less manganese 4 oxide, the rate of reaction could be slower, but there will be the same amount of product. Manganese 4 oxide is again a catalyst. By lowering the temperature, it will lower the rate of reaction, but it will not give you more product. It will eventually give you the same product. So the answer is A, and this is because to the original hydrogen peroxide solution, you are adding more hydrogen peroxide. Therefore, you have a higher number of mole, but the overall concentration of hydrogen peroxide solution is lower because a less concentrated hydrogen peroxide solution is added. So that explains the slower rate. Question 3. In a titration between acid in the burette and alkali, you may need to reuse the same titration flask. Which is the best procedure for rinsing the flask? Now, the flask must be rinsed with tap water and distilled water, and this is to get rid of any remaining alkaline solution or acid solution or the salt solution. It does not need to be dried because whatever number of mole added in this flask will react with acid. If there is water still present from washing the flask, the water will not affect the number of mole of alkali that is present in the flask. So it will not affect the result of the titration. So rinse with tap water and then rinse with distilled water. It should not be rinsed with the alkali because the alkali that is added into the flask must be of known volume. So if you rinse this with alkali, there will be a layer of alkali already in the flask, and this will actually give extra number of mole of alkali and it will affect the titration result. Question 4. Calcium carbonate reacts with hydrochloric acid producing carbon dioxide. Which additional piece of apparatus is also required? Now, carbon dioxide is a gas. It will just leave the flask and therefore the balance reading will decrease. As carbon dioxide is formed, there will be spitting in the solution. Spitting means the solution will jump, all right? And to prevent the solution to jump out of the flask, usually a cotton wool will be put at the mouth of the flask. And also, rate of reaction is the measure of the change of the amount of product over time, or the measure of the change of the reagent over time. So all of the change of amount is measured over time. So we have to have a clock to measure rate of reaction. Question 5. A student wanted to know how the rate of reaction of sodium sulfite with acid varies with time. This reaction produces gaseous sulfur dioxide. Which apparatus is not suitable? A is suitable. You have gas syringe to measure the volume of sulfur dioxide produced over time. C is definitely suitable. This is a change of mass over time, and the mass will decrease over time because sulfur dioxide is a gas and it leaves the flask. D is also suitable. D and A are similar, and also this tissue funnel is submerged in the solution, so whatever gas that is produced will not escape from this tissue funnel out. So all the gas will just go into the gas syringe. B is not suitable. This method is called water displacement method, and it should only be used for gases that are insoluble in water. However, sulfur dioxide is slightly soluble, so the volume that is measured here is actually lower than the volume of sulfur dioxide that is actually produced. And also burette is very hard to use, so usually at school we use inverted measuring cylinder for water displacement methods. Okay, so answer is B. Question 6. A student measured the rate of reaction between calcium carbonate and hydrochloric acid. Which apparatus was used to measure the variable shown on the graph? So the volume of gas can be measured using gas syringe, and time can be measured using stopwatch. Answer is C. Question 7. Copper carbonate powder was heated. The loss in mass was plotted against time as shown. During which time interval is the reaction fastest? Is during the first 2 minutes, because if you draw a tangent line here, this tangent line is the steepest. As the reaction proceeds, the rate of reaction becomes slower and slower, and you can see from the tangent line here becomes less and less steep. So the answer is A. Hydrogen chloride is very soluble in water, whereas chlorine is only slightly soluble in water. Both gases can be dried using concentrated sulfuric acid. Concentrated sulfuric acid is acting as the dehydrating agent here. Which diagram represents the correct method of obtaining pure dry chlorine from damp chlorine containing a small amount of hydrogen chloride? So you only want chlorine. You don't want water vapor. You don't want hydrogen chloride. Take a look at A. It doesn't make sense if you dry the gas first and then you blow the gas into the water, because then your product will be damp, not dry. So A is wrong. B, you first dissolve HCl in water. So HCl will remain here making hydrochloric acid solution, and the Cl2 will be blown into the concentrated sulfuric acid, drying it, and then you will get dry and pure chlorine gas at the end. So answer should be B. Let's take a look at C. Again, C is where you dry the gas first and then you blow the gas into the water. So it doesn't make any sense. Your gas will be damp. And here, the gas is blown into this flask, but not underwater. So here, Cl2 and HCl are above the water. So not all HCl will dissolve in the water. So what you get is still a mixture into the next flask. And again, in the next flask, the gases are not blown into the concentrated sulfuric acid. So not all the moisture is taken away by the concentrated sulfuric acid, which is the dehydrating agent. So D is wrong. Question 9. The diagram shows an apparatus to obtain carbon monoxide. What is the main purpose of Y? When HCl is added into calcium carbonate, then we get calcium chloride, water, and carbon dioxide. Now, calcium chloride is a solution, so it's going to stay in this solution here, CaCl2. Water is also going to stay here, or some of it may evaporate and then it goes as water vapor to the next stage. Carbon dioxide is a gas, so it's going to be carried into the next stage. So if we have charcoal, which is just carbon, the reaction is going to be carbon dioxide and carbon gives us 2 carbon monoxide. This is assuming that the reaction goes to completion, but we also could have a contaminant, an excess carbon dioxide or unreacted carbon dioxide also could still come all the way here. All right, so to make sure that we get only carbon monoxide, we need to eliminate any carbon dioxide. Now, carbon dioxide is an acidic gas, so it can be eliminated by reacting it with something that's alkaline or basic, in which case they will make a salt. And the salt will just be a salt solution and stays in this flask. Okay, and then the rest of the gas will be just carbon monoxide. Okay, so carbon monoxide in this case is collected above water, and it's because carbon monoxide is quite insoluble in water. Okay, so the answer is C. So this alkaline could be sodium hydroxide. Question 10. The oxidation of ethanol to ethanoic acid is often carried out in the apparatus shown. What is the purpose of the condenser? So to ensure that all the ethanol is oxidized to ethanoic acid, we have to heat ethanol with the oxidizing agent under reflux. This instrument is called a reflux. Now, how it works is any ethanol that has not been oxidized, when it vaporizes due to the heat, it will condense back and drip back down into the flask to undergo more reaction. Or any intermediate product will evaporate and then condense back into the round bottom flask. So this way, all the ethanol or all the intermediate product will be converted to ethanoic acid. So the purpose of the condenser is to prevent ethanol from escaping by condensing it back into liquid. Question 11. The diagram shows copper 2 oxide being reduced by hydrogen to copper. After reduction is complete, the burner is turned off, but the flow of hydrogen is continued until the tube is cool. Why is the hydrogen allowed to flow through the tube during cooling? Okay, so the reaction here is copper 2 oxide and hydrogen gives copper and water. Now, when copper is hot, because it's being heated during the reaction, when copper is hot, it will readily react with the air to form copper 2 oxide again. So to prevent this reaction, hydrogen is allowed to flow through the tube during cooling. So this tube is now filled with hydrogen, and copper cannot react with hydrogen. Once copper is cold, then the hydrogen will be stopped. and cold copper metal will not react with oxygen in the air. So the answer here is C. Question 12. Aqueous hydrogen peroxide undergoes catalytic decomposition. The diagram shows part of the apparatus used to measure the rate of decomposition. Which piece of apparatus is connected at position X? Since one of the products is a gas, we can measure the volume of gas over time using a gas syringe. When you draw a gas syringe, especially in the structured questions, you may need to draw a gas syringe. Please draw the dashes. And don't forget to label. And the answer is B. Now, oxygen is very slightly soluble in water. So it will still give us a reasonably accurate volume reading if it's collected above water. So like in water displacement method. Number 13. A gas Y is less dense than air, very soluble in water, and is an alkali. Which method is used to collect a dry sample of the gas? So because it's very soluble in water, we cannot have water displacement method. So A won't work. Less dense than air. Less dense than air means it will float above air. So you don't want to collect it using downward delivery, okay? Because the gas will just be floating back out, right? So B is wrong. B is actually for gases that are denser than air. Next, this gas is an alkaline gas, so it will not react with calcium oxide because calcium oxide is a metal oxide and metal oxides are usually basic oxides. So we can use calcium oxide, which is also a dehydrating agent, to dry the gas. They will not react. Base and base, they don't react. So C is the correct answer. D cannot be used because even though concentrated sulfuric acid acts as a dehydrating agent, but this will react with the gas because the gas is alkaline. So answer is C. Question 14. A gas X is less dense than air and insoluble in water. Which method cannot be used to collect the gas? Less dense than air means it will float above air, and so A cannot be used because if you deliver the gas down here, the gas will just float and escape from the top. B can be used because the gas is less dense than air, so it will remain mainly up here. It will not go down and escape. So B is a correct method. C is a correct method because the gas is insoluble in water, so we can use water displacement method to collect the gas. And D is gas syringe, so we can use that for any type of gas. So A cannot be used. That's it for this video. Thank you very much for watching.